Solve the nonlinear system. X minus 4 is equal to 3y. X squared plus y squared is equal to 8. I'm first going to identify these equations as numbers 1 and 2. Also, just think about this really quickly. We've got a line and a circle. So they might intersect in no points, or 1 point, or 2 points. Let's see. Let's take equation 1 and let's solve it for x, giving x is equal to 3y plus 4. And I'm going to call that equation 3. Now let's substitute this value for x into equation 2. So that we have a 3y plus 4 quantity squared plus y squared is equal to 8. Now let's solve this equation for y. Squaring this binomial gives 9y squared plus 2 times our inner and outer product. So that's 12y times 2, or 24y, plus 16 plus y squared is equal to 8. Here we have a quadratic equation. Let's write it in standard form. Combine your y squared terms. This is a 10y squared plus 24y. Let's subtract that 8 from both sides. 16 minus 8 is 8. Now we have that set equal to 0. Now before I try to factor anything, I'm going to notice that 10, 24, and 8 have a common factor of 2. So I think I'll get rid of that by dividing both sides by 2 and writing this in a simpler form as 5y squared plus 12y plus 4 is equal to 0. Now let's factor it. Our leading terms must be 5y and y to give a product of 5y squared. We know these are both plus signs because we've got plus signs in the trinomial. Now let's get our factors of 4 in here, and I'm going to use a plus 2 and a plus 2. Checking 2y and 10y gives that middle term 12y. Zero factor property says 5y plus 2 is 0, or y plus 2 is 0. So y is equal to negative 2/5, or y is equal to negative 2. Now, we're looking for 2 points of intersection then, and we've got the y values for those points of intersection. Let's determine the x values. I'm going to do that by substituting these y values back into equation 3, which is x equal 3y plus 4. Let's substitute y in there. So x is 3 times a negative 2/5 plus 4. That's a negative 6/5 plus, that's a 20/5. 20 minus that 6 is 14/5. Now let's find the x value that goes with y equal negative 2. I'm going to substitute negative 2 into the same equation 3 right here for y. So x is equal to 3 times negative 2 plus 4. That's a negative 6 plus 4, or a negative 2. Let's describe our solution set now. This solution set contains the points right here where x is negative 2 and y is negative 2. And over here where x is 14/5 and y is negative 2/5. It's always wise to check these solutions back in your original equations, and that check will verify that we do indeed have a solution set.